Yeah, we are able to see.
Okay. So in the previous, we learned about how to create different types of constraints and simple joins, left join, inner join, outer join. Today we are going to talk about a little more into multiple table join and fetching what ones you want and generate different. Okay, so I'll clean up this. Here we have employee address, and you might have practiced it. Okay, that's fine. So should I create a new one? I on this, right? That's why I see all your changes. Let's look at it.
Yeah, I did the same. Sorry.
Yeah, that's fine. I mean, that is meant for you.
Yeah.
Nice. You made a lot of different different.
Yeah, your voice is not clear. It's breaking. We can't hear you.
Yeah, actually your voice is not clear.
Okay. So now I see all your tables. Let's look at what you do. Food. Okay, you did some details. Okay, that's fine. So what I can do is I will create a new schema for myself. Create a new schema. Okay. Fine. Okay, I have created a new schema. See, now you see here so many different things, right? So this is nothing but schema. So let's say you build an application and connecting to Arun database. I mean, Arun is the schema name. So all these different schemas are sitting on one single database server. So that means one server can support any number of applications. So now assume that these are all different applications sitting on the same server. So there won't be any interaction between one schema to other schema. So within the schema, that's where you got the access. When you log in, you get access to see only Arun schema. You don't see all these things because I logged in as a database administrator. That's why I'm seeing every schema that is created on this database server. So now, once you, at the schema level, you can have tables, views, stored procedures, and functions. At the database level, you will see schemas also. Okay? So now, under the training, now I'm going to create. This is this scrolling is not there. Okay. So now I create multiple, give me a minute time, I'm going to create many different tables. Create table, employee, and employee ID, phone number, and first underscore name where cast out 20, some 20 characters.
I guess that number is the int.
Okay, int. Okay, now this table is created. Similarly, I will create a few more tables. So, other table, I'm creating, employee will have address, and then I'm adding address underscore ID int, and then it will have an employee ID, and then other column street underscore name. So we have two tables now. So let's say I'm adding third table. Similarly, some other table like what else we can do? Employee can have hobbies, maybe. I'll create something like employee hobbies. So now hobby underscore ID, and then employee ID, and and then hobby name, what type of hobby it is. Okay. So now I have created three different tables. So now when I'm inserting one record into each table. So employee ID 1, and then first name, go with them. Why? Only one, right? Is there a problem here? Oh, okay.
I guess, yeah, values.
Now mention the column names. That's why
Yeah.
it's a problem. Employee ID, first name, alias 1, and first name is Gold. Okay. So similarly, I will create multiple other records. Insert into address underscore ID, employee underscore ID, and street underscore name. Values, address ID, employee ID, and street name, something, pronoun, common. So, so now I inserted a record into address table also. Insert into hobbies, which requires hobby underscore ID, employee, employee underscore ID, and hobby underscore name, values. So hobby ID 1, employee ID 1, something like this. Perfect. So now what did I do? I created three different tables, and then I inserted one record into each table. Now, so when you want to see a different data of an employee, now I wanted to get employee ID, employee first name, employee street name, and employee hobby. So I want to get all of these information with a single query. So to do that, select star from employee, what you will get? With this you will get whatever the records available on employee. Now, you already know aliasing. Join on join, not on, join, then we need to give the table name. Join address table, addr on addr.employee underscore ID equal to emp.employee ID. So now address will also come. You can see employee, first records are employee columns and second two columns are coming from address. And then I am joining third table hobbies HOB on HOB.employee ID equal to emp.employee ID. So now you're going to get two more records. These last two columns are coming from hobbies table. Now I don't want to repeat employee ID like this. I want only the columns that I'm interested in. So to do that, emp is the first aliasing name. That's here, whatever you're giving here. So give the same thing, emp dot. That means you're trying to get any column on that alias name, emp dot employee ID. That means I am getting employee ID column from emp table. And then emp dot first underscore name. That means I'm getting first name column from employee table. Then addr dot street name. So that means I'm getting street name from address table. And hobbies dot hobby underscore name. That means I'm getting only hobby column, hobby name from hobbies column. Now if you see here. So I'm getting the data, whatever I'm interested in, out of all three different tables. This is how you can generate data by joining multiple different tables, whatever the data that you are interested in. So, I mean, the similar way you can write for 10, 20, any number of tables, there is no limit. But as long as you increase the number of tables, the query execution time, whenever you select this and run, right, that is nothing but query execution. So the query execution time will go longer and longer. So whenever you do the joins and building the complex queries, you need to keep remember, your query needs to be run at an optimal performance. Any questions so far?
No question.
No question.
Okay. So now you have written the query whatever you need. So that's how you generate the result. Now I don't want to write these queries again and again. So that means you can create views. So view means whenever you run that view, internally it will execute all this query and gives you the data that you are looking here. So let's look at how the views works. So now here you see the views here. Create view. So here, I just right click and generate this syntax rather than I write it. You can manually write also, no problem. So here I'm saying employee EMP details. This is my view name as, and whatever the query that you have written. Write the same query here. That's it. And so now if you see here, there is no views available. I'll try to do here. Okay. So now view is created. Now let's refresh this. Okay. So when you click on here, so the new view is getting added, which is emp.details. That's the view name. So now once you create the view, this is all pre-compiled and pre-written queries. is nothing but view. So now I don't need to write the query again. Whenever I need some details, just do select star from EMP details. That's it. I got my data. I don't need to write this query again and again. Once you expose whatever the data that you wanted as a view, any developer or anywhere in your system or some other database wanted to access your data, so you don't need to expose all these tables outside. So you can hide. What is the advantage of view? The advantage of view is you don't need to tell outside people that these columns are which table. So now let's assume all this is not there, only EMP details. So when you do EMP details, we are giving all this information. But whoever is getting this data, they don't get to know from which table these columns are running from. So you're kind of, hiding the internal implementation and giving it as a read-only view to the consumers, whoever is wanted to use this data. That is one advantage, and it's a pre-compiled query, so it will be faster to generate the results than you write your own query and execute the results. Any questions on that view?
No questions.
No.
No question.
So now, if you want to modify, you can modify the view also. So let's see, alter view. I'm just trying to create, define. Okay. So I think so. You can let me do how we can modify it. Alter. I don't see any statement here. Oh. So you can drop, whenever you want to create a new view, ideally what I do is I will copy the query outside and do drop view EMP underscore details. So done. Now the view no more exists. Should refresh all. I'm refreshing all views. Now you can see nothing is there. The view is gone. Now if you want to create a different view on the same name, just create the same name. And now this time, I'm doing a little bit different. I want to expose this column as different employee EMP ID. Whatever the column name that you wanted to expose outside world, you can do that as first name. That's the column name. So whatever the column that is coming, I'm trying to alias in the column name. Street name. Just copy. So now the new view is created. Now again, I do the select star from employee, EMP underscore details. Now you see the column names are changed. Whatever the nicknames that you have given as EMP ID, as first name, as street name, so all those columns are coming up. So this is how you can drop and you can create with a custom names. So that's the whole purpose of generating different views. Any questions?
No question.
No, it's clear.
Okay. So I would like to stop on the database side at this level. I don't want to get into store props and functions at this minute. So I just wanted to give you, high level overview of how database works, what is tables, what is views, how constraints works. So pretty basic stuff that you got so far. Now what I will start with, Spring Framework. So, with the Spring Framework, the next course of action is I'll train you on Spring Framework and how to connect to the database. Whatever the tables that you created, how you can connect from the Spring to the database and read all this data at a server level. That means this is a database server, and to run the Java code, you need an application server. We'll talk about it very in detail. What is the difference between application server and database server? So whatever the code that you write using Spring and Hibernate, whatever the Java-related technology that you use, you need to deploy all your code and the application server, which will internally connect to your this database and read all the data and expose it as a service to the outside world. Or even you can update all these tables. So whatever the training that I so far did on the database level, so this is only for training purpose. In general application implementation, nobody will directly log into the database and insert the values. It all happens through the applications. So do you guys have any understanding on Spring Framework?
No, actually, very.
Okay. So now, in a typical Java-based application, the simplest architecture that you will have is client-server architecture, which will involve 3 different components. Browser is nothing but client. So for the explanatory purpose, I mentioned as browser. This can be any of your browser, Firefox, Internet Explorer, Google Chrome, or your mobile devices, iPad, any type of client that interacts with your application. For example, take Facebook. Facebook can run from your browsers or different mobile devices or tablets. So when you make a call, so the call comes to the server. That means call in the sense when you click on any button, link, or whatever the action that you do on the web page, the communication will come to the server. At the server level, what it does is, depending on whatever is the request, let's say you are trying to fetch your own profile on Facebook, whenever the communications come to the server will understand that you wanted your Facebook profile. Then server will communicate with the database and go through some certain tables and fetch all your profile information from the database. And then the information will be processed in the server, and the response will come to the browser. And whatever the technology used on the browser, your page, the next page will be rendered. That means for every action that you make in the browser, pardon me? Pardon me? Do you have any questions?
No questions. Sorry for the disturbance.
Okay. So whenever you make any click, any activity on your browser, the communication comes to the server and goes to the database, comes back to the server, and comes back to the browser. That's the typical architecture. So now when it comes to the technology stack, most of your web pages can be built using HTML, CSS, and modern JavaScript framework like Angular, React, or any sort of the frameworks can be used to build your web pages. So now, why? Because browser can understand only HTML, CSS, and JavaScript. That's why all your web pages will be built using these technologies on the browser. And at the server level, depending on what server you use, if you are using Java, there are so many different application servers. So when I say server, this is nothing but application server. So there are so many different servers available in the market. Every company released one. IBM has one, and Microsoft has one. I don't think Microsoft. WebLogic is one. There are multiple application servers available. Very popular ones are WebLogic application server, WebSphere application server, Tomcat. So these days, Tomcat is the most favorable application server for most of the companies. So for our training or application building, we are going to use Tomcat, which is open source and license-free application server. WebSphere and WebLogic are licensed, licensed application servers. So now, when it comes to the database, again, just like the application servers, at the database also there are so many different types of databases. As I explained you, there are two major segregations in the database. One is SQL and one is NoSQL. So we are not talking about NoSQL throughout the duration of the course. So that is something we can talk about after 3 months or 4 months. So when coming to the SQL type databases, there are many. Again, Oracle is most popular one, and MySQL. MySQL is also open source database coming from Oracle Corporation, and Oracle is the licensed version. And similarly, Microsoft has MySQL Server, Microsoft SQL Server. And some other companies have Interbase, like there's so many other different databases also available in the market, but most popular is Oracle. And then most of the startup companies are using MySQL. So for us, we are going to use MySQL database that we are already gone through a few sessions around that. So now, when these are the different technologies involved at a different layer. So now when we are talking about Spring Framework, so that is nothing but a framework built on top of Java, JDK, and executes on application server. So we are going to talk about first Spring Framework, and then which has all inbuilt mechanism how to connect to the database and fetch the data from database and process at application server level and sends the response as JSON response. So we'll come to the JSON response also after a couple sessions. So whatever the response that we are sending from the backend will be back. When I say backend, means application server. So whenever any service request comes from the browser, we will send a JSON response to the browser. We'll talk about what is JSON response and all that stuff later on. Let's focus on only the Spring Framework. Now, in the Spring Framework, it's again a design pattern called MVC pattern, Model View Controller. So now, let's talk about what is Model View Controller. I'm just copying the same. So I'm not talking about browser for now. So I'm removing all these layers. Let's talk about only application server. So application server is having Spring Framework, which will have 3 different concepts: model, view, and controller. So the Spring Framework is built on top of MVC design pattern: model, view, controller, design pattern. When I say model is nothing but data, whatever the data that you are getting from database. Controller means whenever the request comes from the UI, the browser, where the navigation should go, which service the navigation should go, how, so you might, when you're using Facebook, you might be fetching photos, videos, graphics, profile, for example. These are all 4 different services. Depending on what button you click, depending on how browser communicating to the server, it comes to the controller. Controller will decide which database, which model to go and which tables to fetch from the database. So all this decision logic, it's more of a routing, which data and what tables and all that stuff. That is nothing but controller. And view in the sense, once the data comes from the model, once you process the data, which view it should go, meaning you are at a home page. Now you want to go to the next page. What view it should go? That is nothing but view. So it's in the view, for our example, what we do is we will give them JSON response. So that's what we generate a JSON response and send back to the customer. When I say view, whatever the data that we are sending back to the client, meaning web client or browser. So that is nothing but view. Controller is business decision logic where it should go. Model is nothing but your data and data processing. So this is a very fundamental design pattern that is used to build Spring framework. Any questions?
No.
Okay. So you guys are able to follow me?
Yeah, we are able to follow.
Yeah.
Okay. So now I will stop at this now. So what you can do is, let me stop.